All right, Algebra 2, welcome back, welcome back. So this is, once again, this is absolute value inequalities. We've kind of done the basics here, but let's go ahead and finish our formal definitions here, or our formal how we're going to do this stuff. The very first thing, just like absolute value equations, again, which makes it nice because now we've got something similar, right? Just like absolute value equations, the first thing that we need to do to solve an absolute value inequality is to isolate the absolute value. In other words, what you want is the absolute value, and then you want some kind of inequality. Less than or equal to, greater than or equal to, and then a value. That's what you're looking for. Okay, that is what you're looking for at this point. Then you're going to rewrite it as a compound inequality. We're going to talk about an and or an or again real quick. And then you're going to solve each inequality in graph. So once you've isolated, right, you've got absolute value. And if it's going to be an and, we're either going to have less than or less than and equal to. So absolute value of stuff in here is less than a number, or absolute value of stuff is less than or equal to a number. It's going to be either less than or less than and equal to. Now, this does have to be a positive value. That does have to be the case. It does have to be a positive value. We'll talk about what happens when a negative value in special cases in a minute. If we do this, the graph is going to be an and. It's going to go between. It's going to look like one of two things. I had this question, I think it's great. Can you have, when you do an and in this case, can I have an open on one and a closed on the other? The answer is no. It's either going to be both open or both closed. So it's either going to look like this, or it's going to look like this if you're using an and. Now let's say you've isolated the absolute value and you get greater than or equal to. So you could have stuff greater than a number, stuff greater than a positive, or sorry, greater than or equal to a positive number. Once again, positive value. Positive value, you're going to be doing, this is an or situation, just like in a boat when you're trying to row. If you're trying to get somewhere, the oars go out. I know, that's fun. The oars go out. That's how you remember it. I know it's spelled differently, but oars go out. So I'm either going to have closed circles and arrows pointing away from one another, or I'm going to have open circles with arrows pointing away from one another. Those are the only two things you can have if you have an or situation. Now, the question you might be asking is, how am I going to do this here? Let's go ahead and talk through a couple more problems. What I'm going to do is I'm going to do numbers 9 and this other one over here. So I'm going to do number 9 and we'll call it 10A or 10B or something like that. All right. So for 9, the number one thing we have to do, isolate the absolute value. So right now, this is kind of nice. It is. We have the absolute value, an inequality, and a value, and it's a positive value. It's greater than or equal to. Greater than or equal to is an or. Greater than or equal to is an or, so I'm going to set it up like that. So 3x plus 1 is less than or equal to negative 5, or 3x plus 1 is greater than or equal to 5. And I'm going to solve these. I'm going to solve these independently. I'm going to subtract 1, so 3x is less than or equal to negative 6. Divide by 3, x is less than or equal to negative 2. Or if I subtract 1, I get 3x is greater than or equal to 4. If I divide both sides by 3, x is greater than or equal to 4/3. This is my solution. And if I was to graph it, it would go out. They would go out. I would put closed dots at negative 2 and 4/3, and then my arrows would go away from each other. All right. Now, number 7 has a few more steps. I like this example though. These are two-step equations. We've already done this with absolute value equations. I love this, right? The first thing we need to do is isolate the absolute value. It is not isolated. I do not have the absolute value and then an inequality symbol and then a number. I got to do that. I'm going to first start out by subtracting 5 from both sides. Now I have 7 times the absolute value of m minus 5 is less than or equal to 70. Still not isolated. It's being multiplied by 7, the absolute value is. So I need to divide both sides by 7. I have the absolute value of m minus 5 is less than or equal to 10. It is at this point where I make my decision, because now I've isolated and I have less than or equal to. This is in case of an and. So I'm going to write it out like this. I've got negative 10 less than or equal to m minus 5, which is less than or equal to 10. I'm going to add 5 to everything. I'm going to end up with negative 5 is less than or equal to m, which is less than or equal to 15. And that is my solution. Your job right now is to do number 10, and then we'll call this 9A, the other one that's down there. When you're done, check your work. All right, now that you're back, go ahead, take a look at number 10. You should have ended up with 3 is less than x, which is less than 4. And then for that 10b, that other one down there, you'll end up with, here, let me make sure we got this. This is the one here. We'll end up with n is less than negative 3 or n is greater than 7. So with that said, we are almost all the way done. We got 2 more things I want to chat about. First thing is, I want you guys to look at number 13 and 14 real quick. We'll just do number 13. There's one more thing we got to look at, or not one more thing, but one more reminder here that we're going to have. Okay. When I have this negative 4 times the absolute value of 2x minus 1, which is less than negative 20, I have to isolate. I still have to divide both sides by negative 4. And I have the absolute value of 2x minus 1, and I've got 5. But if you remember correctly, when you multiply or divide both sides of an inequality by a negative number, you have to flip the inequality. So this becomes actually greater than 5. We had to flip when you divide by an divide or multiply by a negative number, you have to flip sign or flip inequality. You have to flip the inequality. Number 14 is like that also. What I'm going to do for the rest of the problems, the problem types, is I'm going to put a, I'll put the solutions up on Google Classroom for the guided notes, and you'll have to take a look at that. But let's finish this thing off right here. Special cases. The absolute value of stuff, ax plus b, is less than a negative number, or less than or equal to a negative number. So let me just kind of draw this out. Once we've isolated, here's kind of bringing it back to our transformations of graphs. Once we've got it to this point, this ax plus b, the only thing that it can do is shift it left and right, or make it wider or narrower horizontally. That's the only thing that it can do, because we've isolated, we've taken out all the vertical stretch, compression, and reflection, and the vertical translation. So this origin value for this is always going to be on the x-axis. So I'm going to end up with, let's just draw an x-axis. Let's say it's right over here. There's my absolute value, and my negative c value is down here. So to ask ourselves the question, how much of that absolute value is below the negative number? And the answer is none. In this case, if you get the absolute value, you've isolated it, is less than a negative number or less than or equal to a negative number, you have something interesting. You have no solutions. Again, why? Because none of this absolute value is below that line, that negative number. What does that look like in an example? Absolute value of 2x plus 1 less than negative 3. If you graph that, none of this absolute value can be below that line. You just say no solution. Because I know you've been dying to know what happens when you got negative numbers. But let's take this same thing. Let's take this same absolute value here and this same negative c value. How much of that absolute value is above that negative number? Well, it turns out that all of it is. It's not just some of it. This is all of it. All real numbers all real numbers. All of this absolute value is above that horizontal line, that y value, okay? So let's see what this looks like. Isolate, again, 3x minus 5 in the absolute value greater than or equal to -4. All of this absolute value has to be above the negative number. You get all real numbers as your solution. Now, it wouldn't be a guided notes with Mr. Brayman without doing a word problem. And let's go ahead and look at this kind of word problem. You're going to notice that they're very similar to what we did before. And you'd be correct. They are very similar to what we did before. These are, again, 3-level examples. The difference is inequality symbols, right? We've got the thermostat for a house is set to 68 degrees Fahrenheit, but the actual temperature may vary as much as 2 degrees. We've got what it's set for and what it varies by. Write an absolute value inequality to describe the situation, then solve. If we were doing an absolute value equation, we would say the absolute value of x minus the actual, which is 68, equals the variance of 2. Because we'd say x minus 68 equals -2, x minus 68 equals +2, and we get our values. But we're doing inequalities. And in this case, I'm still going to have something like this, but I want this to go between two values. And we would use that as an and. If we're doing ands, we have the absolute value less than or less than and equal to a number. In this case, x minus the actual. And we're going to have the variance over here. We're going to say that this is going to be less than or equal to 2. And here's why. Because this is an and statement, I would say -2 is less than or equal to x minus 68, which is less than or equal to +2. Well, how do I solve for x? Same way we've been doing it. Add 68 to everything. 68 here, 68 here, 68 here. I have 66 is less than or equal to x, which is less than or equal to 70. And you're gonna say, Mr. Brayman, how is that different from what we did with the equations? And there's a key difference, because with the equations, we're saying, what are the extremes? The highest could be 70 and the lowest could be 66. But we're saying inequality is it could be anywhere in between these things. So x, your temperature could be anywhere between 66 and 70. So it could be 67. Yeah. Could it be, I don't know, 68.5? Yeah, because it's between those values. All right. So that's what we're looking for. What's the possible range of temperatures? Between 66 and 70 degrees Fahrenheit. Those are your examples. Again, check your solutions on your guided notes with what's been posted on Google Classroom. And with that, take care. Have a great day.